Good morning, everybody. Today we'll continue the class. We are doing the analysis of trusses, that is finding out deflection using Castiglione's theorem. So this is the next problem. A, B, C, D and E is given. This is 4 meters, and this is 4 meters. Now find displacement at C under load P. Given area is 250 into 10 to the power of minus 6 meters square, and Young's modulus also 250 into 10 to the power of 6 kilonewton per meter square. So what we have to do here is first find out the reactions. So here from A, fatigue moment, RE, this is RE, RE into 4, this is this direction, and this is other direction, is equal to P into 8. Therefore RE is equal to 8P by 4 will become 2P. This is 2P. Now we can see we are having only two supports. If this is 2P, here we should have other direction 2P left side. This 2P is right side. This should be 2P left side. And when we see the vertical forces for the whole structure, we are having downward P force. So we should have upward P force, and at A, this is hinge will be having two reactions, so this will take upward P. This is how we have to find out the reactions. Then we go for method of joints. First we will take, in this we have to see which joint is having less number of members. So we have to start the finding forces from that joint. See, joint C will start. Joint C. Force downwards P. We have to assume all the forces away from the joint. This is C, D, CD away from joint, and CB away from joint. So inclined member will have horizontal and vertical components. So if we see vertical forces is equal to 0, P downwards, this is upwards. That is P is equal to, this is FCB, vertical means sine 45. Why 45? Because this is 4 meters, this is 4 meters, so this will be 45 degrees. And all the inclined numbers are 45 degrees. So FCB P by sine 45, which will be equal to P root 2. BC, CD, ED, AE, AD, BD. And define length. AB is 4, BC is 4 root 2 by trigonometry. Again 4, 4, 4, 4 root 2, and also BD 4. Now then we have to find force F. So we have found out force for FCB. BC and CB is same, so we put it as root 2 P. Next, for the same joint we go for sigma H is equal to 0. So we have this force and this force, both same direction. So I write FCD, we don't know, plus FCB cos 45 degrees equal to 0. FCD is equal to minus FCB cos 45. FCB already got minus P root 2 cos 45 1 by root 2 becomes minus P. FCD is equal to minus P. FCD is equal to minus P. Or joint C. Then we go for joint C. We have to see, we will go for joint B. So we have like this. Horizontal force away from joint, vertical force away from joint. This is inclined. This is C. This is B. This is A, and this is D. Inclined will have components vertical, horizontal. So in this we have to go for sigma V is equal to 0. What is sigma V? FBC sin 45 plus FBD is equal to 0. So FBD is equal to minus FBC sin 45. FBC we got root 2P minus of root 2P 1 by root 2. Again it is minus P. FBD minus P. FBD is equal to minus P. Then we go for sigma horizontal is equal to 0. So we are having this force, both are opposite. FBA is equal to FBC cos 45. FBA is equal to FBC cos 45. FBC is root 2P. Root 2P into 1 by root 2. P. FBA is equal to P. FAB or FBA is same, so we write this. So joint C and joint D is over. Joint C and joint B. Then we will go for joint D. So joint D is away from joint, incline. All away from joint. This will become horizontal and vertical. So now we have to see which force is unknown. With that we have to find out. Here we know this is B, this is D, this is C, this is E, and this is A. So we know this one and this one. We don't know this one and this one. So we'll go for sigma V is equal to 0. So DB is equal to B, FBD vertical plus FDA sine 45 is equal to 0. So FDB is equal to minus FDA, not like this. We don't know this one, so we write like this: FDA is equal to minus FDB by sine 45. FDB we know. FDB and BD is minus P. So we write minus of minus P 1 by root 2 will become P root 2 FDA. FAD or DA is P root 2. And then we go for sigma H is equal to 0, horizontal force. So here FDE plus FDA cos 45 is equal to, this both are left side, this is right side, is equal to FDC. So we don't know FDE. FDE is equal to FDC minus FDA cos 45. So FDC and CD, there is minus P minus FDA. FADDA is P root 2. P root 2 1 by root 2 become minus 2P. FDE is equal to minus 2P. DE and ED is same, so minus 2P. So the only thing is AE is remaining. AE. So let us take joint E. Joint E is away from joint. This is right side. This is 2P. this is D, this is E, this is A. Now if we take sigma V is equal to 0, so we are having only F E A is equal to 0. No other force, therefore it will be 0. F A E or E is equal to 0. This is how we got all the forces. Now what we have to do? We have to do one more column, F square L. This square into 4. This will become P square 4. This will P square 2 into 4 root 2. 8 root 2. Again this is P square 4. P square 2 into 2, 4 into 4 is 16. This is 0. P square 2 into 2, root 2 into root 2 is 2. 8 root 2. This is P square 4. After this we have to do summation of F square L, which is will be equal to 50 point, all if you multiply, add all these things, 50.627 P square. After this, strain energy U is equal to sigma F square L by 2AE, which is equal to 50.627 P square by 2 into AE. Now delta is displacement under P is equal to dou U by dou P. It will become 2 into partial differentiation of U with respect to P. So P square will become 2P, 2 into P into 50.627 by 2 into A into E. Now substituting all the values, 2 into P is given as P is given as 100 kilonewtons. Hundred into 50.627 divided by 2 into 250 into the power of minus 6 into 250 into 10 to the power of 6. So this will get the value 0.081 meters. One meter is 10 to the power of minus 3 mm, that will become 81 mm. This is how we have to do. Coming to the next problem. Here again same thing. Force P is acting right side at this joint. What is the question? Find horizontal displacement at C. So what we have to do, find the total strain energy, then we have to do the partial differentiation with respect to P. We will be getting the value. Same way we have to do here. Given P is 120 kilonewtons, A, all these things. So first thing what we have to do here is finding reactions. See here, RD into 6 plus 6 is 12 meters. This is anti-clockwise. And P is right side going clockwise. And the distance is 3. P into 3, RD is equal to P by 4, upside. So P by 4 is upside. So downward force should be also P by 4, which is equal to, so we write at A, only A is, we are having only support at A, therefore at A the downward force will be P by 4. RA is P by 4 downwards, RD is P by 4 upwards. Starting the method of joints. Joint A, here P, again in this structure load P, see we have to see the equilibrium of external forces. External forces should be in equilibrium. So when P is acting right side, so one more P should be acting to the left side. So we are having here hinge support, this is roller support. The roller support cannot have two reactions. Only hinge support can have two reactions, therefore at hinge support we have to take P left side. Everywhere in all the trusses, wherever hinge support will be there, we will be having two reactions, and roller support will have one reaction. So therefore at A we are taking left side P is acting. In joint A, we have drawn the free body diagram. First vertical force is equal to 0. One force downwards is P by 4 and upward force is FAB sin 45. Again 45 here because it is given in the problem, already it is given. So you have FAB is equal to P by 4 sin 45, which results in P by 2 root 2. So we will draw the table column like this. We have given all the lengths here, then P by 2 root 2. In the same way, taking horizontal forces, 1, 2, 3 forces are there. 2 forces to the right side, 1 force to the left side. This is FAE, no cos or sine because it is horizontal force. This is P. Here it will be FAB component, so cos 45. So P is equal to FAE plus FAB plus FAB cos 45 degrees. So FAE will become P minus FAB cos 45 degrees. FAB we have got previously, just we have to put whatever we got, P by 2 root 2. So we will be getting FAE is equal to 3P by 4. In the same way we will be doing for joint B, then joint E, and for joint D. We will be getting the same procedure is there. Length, force, F square L, and everything we have to do. Summation and horizontal displacement with respect to dou U by dou P, we will be getting the same thing we have to do. So here we will be getting 16 mm horizontal displacement. So this is how we go with the trusses. First find out the strain energy. So same procedure is there. For example, for some problems, what it will be given directly at P, at C 100 kilonewtons will be given. So we should not solve the problem using 100 kilonewtons, but we have to put some variable P there. Wherever force, wherever displacement is required, we have to put variable at that point. Because why we have to put variable is, at the end we have to do differentiation, the partial differentiation with respect to that force. So if you put the 100 kilonewtons, you cannot do the differentiation. That's why we have to put some variable. Then after doing the partial differentiation, after that substitute the value of P. Okay. So this is over. Then we'll go for the beams. So this